Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. Today we are going to understand the concept of adapting Poisson distribution for different intervals. Now to understand this particular concept, let's take the example of the check post which we took in one of the videos. Suppose there is a check post and we say that through this check post on an average 5 cars pass every 10 minutes. Okay, if this is a scenario, then we had seen that the number of cars passing every 10 minutes could be represented by a discrete random variable x, where x was a random variable representing number of cars passing through the check post every 10 minutes. Number of cars passing the check post every 10 minutes. And we would say that x follows Poisson distribution with the average or the mean value being 5. This mean value was defined for 10 minutes and x was also defined for 10 minutes. Correct? This is our lambda. This lambda equal to 5 was given for 10 minutes and x was also defined for 10 minutes. And we have seen questions on this interval only, like if they ask you to find out probability of x is equal to 2, that means find the probability that in a randomly chosen 10 minutes exactly 2 cars pass through the check post. Or we have seen a question like this: find the probability that in a randomly chosen 10 minutes less than 3 cars pass through the check post in a particular chosen 10 minutes. Correct? But if they ask you find the probability that less than 3 cars pass through the check post in a randomly chosen 1 hour. So see here what happens. Here we have changed the interval. And what's the interval here? Interval of time. Here the interval of time was 10 minutes and now we have taken the interval of time here as 1 hour. Similarly, let's take an example of a metal plate a company manufactures. Okay, and a metal plate has 2 flaws every 10 meter square area. Okay, on an average. So we would have represented here the number of flaws every 10 meter square by a discrete random variable y, and we would have said y would follow a Poisson distribution with the parameter 2. Okay, where lambda is equal to 2. Here if you see, here the interval given is basically the interval of space, not the interval of time but the interval of space, and the space they have given is 10 meter square. Okay, and here y also is defined for 10 meter square. But if they ask you the question, find the probability that more than 2 flaws are there in a randomly chosen 100-meter square metal plate. Okay, so if you see here, now they have changed the interval of space. Here the interval of space was 10 meters square. Now they have changed the interval of space to 100 meters square. So how to find out the probabilities when the intervals are changing, interval of time or the interval of space are changing? Okay, this can be very easily solved by understanding the concept that in Poisson distribution, okay, the events occur at constant rate. In Poisson distribution, events occur at constant rate. Events occur at constant rate. Okay, so when the events occur at constant rate, we can say that the mean number of occurrences for a given interval or for a required interval or if the interval is given is proportional to that interval. Now what do we mean by this? Let's take the case of the check post again. So if I take the case of a check post, okay, here let me draw a small table. The mean and the interval, the time interval they have given, interval of time here they have given initially. What mean they gave? They said that 5 cars pass every 10 minutes. So 5 cars pass every 10 minutes. Now in the question they had asked that find the probability that less than 3 cars pass in a randomly chosen 1 hour. So they have changed the interval. So they are talking about 1 hour. So this 1 hour is basically consisting of how many 10 minutes interval? If you see 1 hour is 60 minutes. So can I say this is nothing but 6 into 10 minutes or 6 10 minutes like this? So if we are increasing the interval 6 times, we will increase the mean also by 6 times. So the new mean will be equal to 30. Okay, this will be our new mean. And now we can represent, we can take any other letter like say W, okay, as a letter to represent the number of cars passing through the check post for a randomly chosen hour. Okay, why we are changing that particular letter? Why we are not using the same letter? Because here the letter X was representing the mean number of cars passing in a randomly chosen 10 minutes. Because the interval is changing here, it has been changed to 1 hour. It's better to change the letter which represents the Poisson distribution. So W represents the number of cars passing through a randomly chosen 1 hour, and it will have a new mean that is equal to 30. Okay, similarly for the metal plate, if you take, for the metal plate what they had given, again let's try to make a table quickly. They had given as a mean and they had given some interval initially. Okay, the mean, they are given that for every 10 hours of space, that means 10 meter square space, there were 2 flaws on an average, but they are asking for 100 meter square. Okay, they are asking for 100 meter square. Now this 100 meter square is how many 10 meter squares? It is 10 times 10 meter square, correct? So because we are increasing the interval of space by 10, we will increase the mean also by 10. So I can make it as 2 into 10, which is equal to 20 flaws. Now again, we can represent, take a new letter, like say S, we can take a letter where S represents the number of flaws, okay, in a randomly chosen 100 meter square plate. And this number of flaws will follow a Poisson distribution with a mean value of 20 for that 100 meter square on an average. Okay, so by changing the interval, we can change the mean, because the events occur at a constant rate. The means are proportional, gets proportional to the interval which we take. Okay, that's it for this particular video. In the coming videos, we will see certain examples how to tackle questions on this particular adaptation of Poisson distribution to different intervals. That's it for this video. We will meet in the next video. Till then, Radhe Radhe.